Welcome to our exploration of ethical considerations in genetic engineering. As science advances, the ability to manipulate genes has opened up incredible possibilities, from curing diseases to enhancing crops. However, with these advancements come complex moral questions. In this video, we'll journey through the landscape of genetic engineering, examining the ethical dilemmas that arise and the debates that shape our understanding. Let's begin by understanding what genetic engineering is and why it's such a pivotal topic in modern science and society. Genetic engineering refers to the direct manipulation of an organism's DNA using biotechnology. This process allows scientists to add, remove, or alter genetic material at particular locations in the genome. The technology is used in various fields, including medicine, agriculture, and industry. While the potential benefits are vast, such as developing disease-resistant crops or treating genetic disorders, the power to change life at its most fundamental level raises profound ethical questions that we must carefully consider. Understand the ethical landscape. It's important to look at the history of genetic engineering. The field began in the 1970s with the development of recombinant DNA technology. Since then, breakthroughs like the cloning of Dolly the sheep and the CRISPR gene editing tool have pushed the boundaries of what's possible. Each milestone has sparked new ethical debates, forcing society to reconsider what is acceptable and what should be off-limits. This historical context helps us appreciate the complexity of the issues we face today. Genetic engineering offers a range of potential benefits. In medicine, it can lead to cures for genetic diseases and more effective treatments. In agriculture, it enables the creation of crops that are more nutritious and resistant to pests or harsh climates. Industrial applications include the production of biofuels and biodegradable materials. These advancements promise to improve quality of life and address global challenges, but they also come with responsibilities and risks that must be managed ethically. Despite the promise, genetic engineering also presents significant risks. Unintended consequences, such as the creation of new diseases or ecological imbalances, are real concerns. There's also the risk of misuse, where genetic technologies could be used for harmful purposes. These risks highlight the need for careful oversight and ethical guidelines to ensure that the technology is used responsibly and for the greater good. One of the most debated areas is the genetic modification of humans. This includes gene therapy to treat diseases, but also the possibility of enhancing traits like intelligence or physical ability. The idea of designer bodies raises questions about fairness, consent, and the definition of what it means to be human. Should we allow genetic enhancements, or should we limit interventions to treating serious illnesses? These are questions that challenge our values and societal norms. Ethical considerations also revolve around consent and autonomy. In the case of genetic interventions, especially those performed on embryos or children, the individuals affected cannot give informed consent. This raises concerns about autonomy and the right to make decisions about one's own genetic makeup. Balancing the potential benefits of early intervention with respect for individual rights is a delicate ethical challenge. Justice and equity are central to the ethical debate. If genetic engineering technologies are expensive or only available to certain groups, they could widen existing social inequalities. Access to these technologies must be fair and just, ensuring that benefits are shared broadly and not limited to the privileged few. Addressing these concerns is crucial for building a just and inclusive society. Common ethical concern is the idea of playing God, the belief that humans should not interfere with the natural order of life. Some argue that altering genes crosses a moral boundary, while others believe that using our knowledge to alleviate suffering is a moral imperative. This debate touches on deeply held beliefs about the role of science and the limits of human intervention. Genetic engineering doesn't just affect humans, it can have significant impacts on the environment. Genetically modified organisms released into the wild may disrupt ecosystems, outcompete native species, or cause unforeseen consequences. Careful risk assessment and monitoring are essential to minimize harm and protect biodiversity. Ethical stewardship of the environment is a key responsibility for those developing and using genetic technology. Genetic engineering is often used in animals for research, agriculture, or medicine. This raises important questions about animal welfare. Are genetically modified animals suffering? Are their needs being met? Ethical guidelines must ensure that animals are treated with respect and that their welfare is prioritized, balancing scientific progress with compassion. Effective regulation and oversight are essential to ensure that genetic engineering is conducted ethically. Governments and international organizations play a key role in setting standards, monitoring research, and enforcing laws. Transparent processes and public engagement help build trust and accountability, ensuring that the technology serves the public interest. Ethical standards for genetic engineering vary around the world. Some countries have strict regulations while others are more permissive. These differences reflect cultural values, religious beliefs, and historical experiences. International cooperation is necessary to address cross-border challenges and ensure that ethical standards are upheld globally. Public engagement is crucial in shaping the ethical landscape of genetic engineering. Open dialogue between scientists, policymakers, and the public helps ensure that diverse perspectives are considered. Education and transparent communication empower people to make informed decisions and participate in the debate about how genetic technology should be used. Religious and cultural beliefs play a significant role in shaping attitudes toward genetic engineering. Some traditions view genetic modification as interfering with divine creation, while others see it as a way to fulfill human potential. Understanding and respecting these diverse perspectives is essential for ethical decision-making in a multicultural world. Collection and use of genetic data raise important privacy concerns. Who owns genetic information? How is it stored and protected? Ensuring the confidentiality and security of genetic data is vital to prevent misuse and protect individual rights. Ethical frameworks must address these issues as genetic testing becomes more widespread. Who owns genetically engineered organisms or genetic sequences? The issue of patents and intellectual property is a contentious one. While patents can incentivize innovation, they may also restrict access to important technologies or create monopolies. Balancing the interests of inventors with the public good is a key ethical challenge. Genetic engineering technologies can be used for both beneficial and harmful purposes, a situation known as the dual-use dilemma. For example, the same techniques that can cure diseases could also be used to create biological weapons. Managing this risk requires robust ethical guidelines, oversight, and international cooperation. Precautionary principle suggests that when an action could cause harm, even if some cause-and-effect relationships are not fully established, precautionary measures should be taken. In genetic engineering, this means proceeding carefully, especially when the long-term consequences are unknown. This principle guides ethical decision-making in the face of uncertainty. Golden rice is a genetically modified crop designed to combat vitamin A deficiency. While it has the potential to save lives, it has also faced criticism over safety, environmental impact, and corporate control. This case highlights the complex interplay of ethical, scientific, and social factors in genetic engineering. Gene therapy offers hope for treating genetic disorders by correcting faulty genes. However, it also raises ethical questions about safety, access, and the potential for unintended consequences. Ongoing research and public debate are essential to ensure that gene therapy is developed and used responsibly. In 2018, a scientist claimed to have created the world's first genetically edited bobbies using CRISPR technology. This announcement sparked global outrage and renewed calls for stricter ethical oversight. The case underscores the need for clear guidelines and international consensus on the limits of human genetic modification. Innovation in genetic engineering must be balanced with ethical considerations. While pushing the boundaries of science is important, it should not come at the expense of safety, justice, or human dignity. Ongoing dialogue between scientists, ethicists, and the public is essential to navigate this balance. Various ethical frameworks guide decision-making in genetic engineering. Utilitarianism focuses on maximizing overall benefit, while deontological ethics emphasize duties and rights. Virtue ethics considers the character and intentions of those involved. Understanding these frameworks helps clarify the values at stake and inform responsible choices. Ethics committees play a vital role in reviewing genetic engineering research and applications. These committees bring together experts from diverse fields to assess risks, benefits, and societal implications. Their work ensures that ethical standards are upheld and that research is conducted responsibly. Transparency and accountability are essential for maintaining public trust in genetic engineering. Researchers and companies must be open about their methods, goals, and potential risks. Accountability mechanisms ensure that those who misuse the technology are held responsible, reinforcing ethical standards. Education is key to empowering people to engage with the ethical issues surrounding genetic engineering. Schools, universities, and public forums can provide information and foster critical thinking. An informed public is better equipped to participate in debates and make decisions about the future of genetic technologies. The media plays a powerful role in shaping public perceptions of genetic engineering. Accurate, balanced reporting helps inform the public, while sensationalism can fuel fear or unrealistic expectations. Ethical journalism is essential for fostering a well-informed and thoughtful public debate. Genetic engineering decisions made today will affect future generations. Ethical considerations must include the long-term consequences for people who cannot yet speak for themselves. This responsibility calls for caution, foresight, and a commitment to leaving a positive legacy. Genetic engineering has the potential to address global health challenges such as infectious diseases and malnutrition. However, ethical considerations must guide how these technologies are developed and distributed, ensuring that they benefit all people, especially the most vulnerable. The commercialization of genetic engineering raises questions about profit motives and the public good. While private investment drives innovation, it can also lead to conflicts of interest or prioritize profits over ethical concerns. Striking the right balance is essential for responsible development. As genetic testing becomes more common, there is a risk of genetic discrimination. Employers or insurers might use genetic information to deny opportunities or coverage. Laws and ethical guidelines are needed to protect individuals from discrimination based on their genetic makeup. Gene drives are a powerful genetic engineering tool that can spread specific genes through populations rapidly. While they offer solutions for controlling pests or disease vectors, they also pose risks to ecosystems. Careful ethical consideration and environmental assessment are essential before deploying gene drives. Genetic engineering enables personalized medicine where treatments are tailored to an individual's genetic profile. This approach promises better outcomes but also raises questions about access, privacy, and the potential for inequality. Ethical frameworks must guide the development and use of personalized medicine. Public policy and legislation play a crucial role in shaping the ethical landscape of genetic engineering. Laws must keep pace with scientific advances, balancing innovation with protection of individual rights and public welfare. Ongoing review and adaptation of policies are necessary as the field evolves. Ethical leadership is needed at all levels, from scientists and industry leaders to policymakers and educators. Leaders must set a positive example, prioritize ethical considerations, and foster a culture of responsibility. Their actions shape the direction of genetic engineering and its impact on society. Community involvement ensures that diverse voices are heard in the ethical debate. Local communities may be directly affected by genetic engineering projects, especially in agriculture or environmental interventions. Engaging communities in decision-making fosters trust and leads to more ethical outcomes. Unintended consequences are a constant risk in genetic engineering. Even well-intentioned interventions can have unexpected effects on health, society, or the environment. Ethical decision-making requires humility, ongoing monitoring, and a willingness to adapt as new information emerges. Trust is fundamental to the acceptance of genetic engineering. Building trust requires transparency, honesty, and a track record of ethical behavior. When people trust scientists and institutions, they are more likely to support responsible innovation and engage in meaningful dialogue. Ethical conduct in research is essential for advancing genetic engineering responsibly. Researchers must obtain informed consent, minimize harm, and respect the dignity of participants. Adhering to ethical standards protects individuals and upholds the integrity of science. Taking a precautionary approach means being careful and deliberate in the face of uncertainty. In genetic engineering, this involves thorough risk assessment, public consultation, and readiness to halt or modify projects if new risks are identified. This approach helps safeguard people and the environment. Ethical innovation means developing new technologies in ways that respect human rights, promote justice, and protect the environment. In genetic engineering, this requires ongoing reflection, dialogue, and a commitment to the common good. Ethical innovation is the path to a better future. Mistakes are inevitable in any field, but learning from them is essential. In genetic engineering, past errors have led to improved safety protocols and ethical standards. A culture of learning and accountability helps prevent future harm and builds a foundation for responsible progress. As we look to the future, the ethical challenges of genetic engineering will only grow more complex. Ongoing dialogue, robust ethical frameworks, and a commitment to justice and responsibility will be essential. By working together, we can harness the power of genetic engineering for the benefit of all. Conclusion: genetic engineering holds immense promise but also poses significant ethical challenges. By considering issues like consent, justice, environmental impact, and the precautionary principle, we can navigate these challenges thoughtfully. The future of genetic engineering depends on our collective ability to balance innovation with ethical responsibility, ensuring a better world for generations to come.